So let's revise what we have gone through so far. Okay, first of all, we understood about AWS, introduction to AWS. Okay, what is cloud computing? What is AWS? Couple of services of AWS. We went through the overview, and after that, we started with the first service that is called S3. S3 and Glacier. So we know that S3 is an object storage service. Basically, they have buckets. In the buckets, we can store objects. In S3, we understood about how buckets are regional. Okay, uh, and on top of that, we understood about the object life cycle. Okay, what is the metadata? What is the signed URL? uh, we also understood about Glacier, because since Glacier is archival storage, what is the retrieval time? And the most important thing on the S3 is the availability and durability. We looked into that. We also understood about the cost. Then we second service of the AWS, which we started, was EC2, Elastic Compute Cloud. So what is EC2? EC2 is nothing but a service of AWS which gives you virtual servers or virtual computers or virtual instances. What is the main components of EC2 are, like there is AMI. On AMI has the information about what kind of OS you want. Is there any kind of metadata or user data you want? Uh, what kind of block storage you want? Okay, and what else? Yeah, that this is all the information that AMI has. Then we also looked about EBS. Okay, EBS is nothing but a block level storage, generally used for the virtual servers like EC2. Okay. Uh, we also understood about security groups, I believe. Today we are going to look more into security groups in the VPC section. Uh, and yeah, we looked into how to launch instances, what is the life cycle of instances. Okay, we also understood more about different types of EBS. Okay, so let's start today's topic with what is called virtual private cloud. Okay, VPC, Amazon VPC. So what is virtual private cloud? Amazon VPC is a custom defined virtual network within the AWS cloud. So as the name says, virtual network. So basically it is a virtual network. So for example, if you have created a VPC, okay, in the VPC only you can create an EC2. Okay, if you want to create any resources like EC2 or EBS, okay, everything is supposed to be in a VPC. So first of all, you have to create VPC, but Amazon by default gives you one VPC. uh, so what happens is VPC isolates your resources. It virtually isolates your resources. For example, you have a set of resources and you have another set of resources, but you want to isolate them. So what you can do, you can create two different VPCs, and in two different VPCs you can create your separate resources. So basically those resources will be isolated by a VPC. Okay, so what are different things which we should understand about VPC are network layer, subnets, IPv4 address range. Okay, so first of all, let's understand networking layer. So as I mentioned, that VPC is nothing but a virtual private cloud. Okay, it is a virtual network, so obviously it has some networking layer. Okay, so if you see this diagram here, okay, we have the outer layer is the AWS, that whole AWS cloud. Inside that, the second box, if you see, that is nothing but a VPC one. If you see this VPC one, so basically you have created a VPC one. Okay, so this is a networking layer. This VPC is nothing but a network layer. Okay, so whatever resource are there in that VPC, those are inside a network layer. Okay, so now there is second layer that's called subnets. Subnets is nothing but basically what you do in a VPC, you try to create different subnetworks. Okay, why different subnetworks? because each subnetworks will be in different availability zone. Okay, each subnetwork will be in different availability zone, so that you can achieve high availability. Okay, so if you see here, this is a subnet 1 which is in availability zone A, and here it is a subnet 2 which is in availability zone B. Okay, you see in the subnet 1 there are 3 EC2 instances, and in subnet 2 also there are 3 EC2 instances. So basically what you have done, you have created a high available architecture. How you have created it? You have managed to create two different set of EC2s in two different availability zones, and those availability zones are nothing but they are something called subnets. Okay, in VPC they are called subnets. So with help of subnets, what you can do, you can create different parts of the network of your VPC. Okay, then there is something called IPv4 address. So obviously every resources has some IP address. Okay, EC2 has some IP address. Okay, and so it means that what we have to do, in VPC we specify a IP range. Okay, IP address range. So if you see here 10.0.0.0/16, this is a IP address range. In this IP address range is associated with this VPC1. So what it means that all the IP address in that range will be associated with that VPC1. Okay, so for example, if you create any resources and you want to associate IP address to that resource, that IP address has to be in this range. Okay, and now if you see again in subnet 1 and subnet 2, there are two different IP address range. Okay, you for a VPC you have created a whole range, but now you have to divide that range for different subnets. Okay, because any VPC, sorry, any instance, any two different resources cannot have same IP address. So what you do generally, for subnet 1 you give a particular range, and for subnet 2 you give a different range. So you see here, for subnet 1 we have given IP range of 10.0.0.0/24, but for subnet 1 we have given the range of 10.0.1.0/24. Okay, and both IP range are part of this whole bigger range that we have defined in our VPC1. Okay, so three things here we have to understand about the basics of VPC. VPC is nothing but a virtual network. Okay, a virtual network. With help of VPC you can isolate your resources. Okay, uh, in VPC there are different sub networks that you can create. Okay, you have choice to create sub networks in different availability zones, or you have choice to create sub networks in same availability zones also. Okay, uh, obviously because we want to achieve a high availability, we create sub networks in different availability zones. But I will show you some architectures right now, which are some complex architectures, and we will understand more about how VPC helps to create those high available architectures. Okay, and the third thing is the IP range, IP address range. Okay, so first of all you have to specify a IP range for your VPC, and then for all the subnets that you have created you have to specify different IP range for all the subnets, which should be which should be a part of your overall IP range that you defined for the VPC. Okay, so let's see some diagrams. Let's try to see some different kinds of architectures so that we can understand more. So here if you see, okay, so if you see this one, okay, what we have done is the outmost box is nothing but your AWS. Okay, in all the AWS diagram, whatever the architectural diagram of AWS you will see, the outmost layer is the AWS cloud. Okay, so everything happens inside AWS cloud. So we have just created our boundary, the outmost boundary. After that you see the dashed orange boundary. Okay, which is nothing but VPC. Okay, which is nothing but VPC. So you see here in your VPC you have two availability zone. Okay, availability zone US East 1A and availability zone US East 1A. Okay, why are these same availability zones? There must be some issue with this. Overall, you see we have created a VPC in US East region. Okay, the region is US East, and in US East region we will create different sub networks. Okay, these sub networks will be in different availability zones. Okay, so you see there is a first box here, okay, which is US East 1A, and there is the second box which should be another availability zone. Okay, now you see there is one private subnet, there is one public subnet, there is another private subnet, and there is another public subnet. So overall what you can see is there are two public subnets and there are two private subnets. Okay, for now I will explain what is the meaning of public and private, but let's just you should be able to see that in this VPC we have created four different subnets. Okay, we have created four different subnets. Okay, now obviously what is public subnet? Public subnet is nothing which has access to internet. Okay, and private subnet is something which does not has access to internet. Okay, you see this is nothing but AWS cloud. These are resources in, so these resources, some of these resources might have connection to internet and some of these resources will not have connection to internet. Okay, that is what you can define using something called internet gateway. So what we have done here, we have attached an internet gateway to our VPC. Okay, for now just assume that just understand internet gateway is a service. Okay, internet gateway is a service, okay, which is in the VPC section. So internet gate, what it does is internet gateway is capable to give internet access to your VPC. Okay, so what it means that if we have attached internet gateway to this VPC, now our VPC will be able to communicate to internet. Okay, but this is just step one. There are a couple of other things that you have to do, that you have to define, so that your resources should be able to communicate with internet. Okay, so now if you see there is something called route table. Okay, there is something called route table here also and here also. So what is route table? Okay, route table is nothing but it specify how your traffic is going to be routed. Okay, a route table has some set of rules. Those rules will specify how your traffic is should be routed. For example, okay, now in public subnet and private subnet, as I said, public subnet is something which will have connection to internet, and private subnet is something which will not have connection to internet. So if you see the route table, okay, if the route table in the right side, if you see this is connected to internet, and this is connected to both public subnet 1 and public subnet 2. Okay, but this right side route table is not connected to private subnet 1 and private subnet 2. So you see what is happening here, we must have specified some rule in this route table. Okay, this whenever you see a line joining, it means the traffic is allowed. Okay, so from this route table you can understand this: public subnet 1, the traffic from public subnet 1 will travel to route table, and from route table it can travel to internet gateway. Similarly, from public subnet 2, traffic can travel to route table, and from route table it will travel to internet gateway. But if you see private subnet 1, there is no direct connection to internet gateway. Okay, in private subnet 1 there is no direct connection to internet gateway. So okay, I hope the concept of subnet is clarified here. Okay, I can explain you once again. This whole VPC will have some IP range. These four different subnets will have different IP range, which will be the part of our overall range that we have specified in our VPC. Okay, and we have internet gateway. Okay, internet gateway allows you to allows your resources to communicate with internet. Okay, there is route table which will specify how your traffic is going to travel. Okay, so if you see in the private subnet, okay, in the private subnet, if you see the route table connection is connected to something called NAT gateway, which is in the public subnet 1. Okay, so for now just don't get confused what is NAT gateway. Okay, just understand that private subnet 1, okay, traffic from private subnet 1 can only be routed to NAT gateway. Okay, as per the route table, okay, which is defined here on the left side, uh, it says that traffic from private subnet 1 and 2 can only travel to NAT gateway. Okay, you see now, all the resources in private subnet 1 and 2 can only travel to NAT gateway, they cannot travel further. Okay, but all the resources in public subnet 1 and public subnet 2 can travel, can communicate with internet. Okay, so what is NAT gateway? NAT gateway is a way, it is a way through which the resources on your private subnet can communicate to internet. Okay, why we are, okay, I will repeat. NAT gateway is a way through which resources in our private subnet can communicate to internet. Okay, now why we are making it complex? If we want something from private subnet to communicate to internet, why cannot we just directly route it to internet gateway? Because as I said, we don't want this public. Okay, we don't want direct connection. There is a purpose why we want connection to internet. For example, if you want to install some software or download some patches, obviously you will need connection to internet. So in that case, what is going to happen is, these the resources on private subnet will communicate with NAT gateway, and then NAT gateway will communicate with internet gateway. So in this way, you can download softwares or download patches to the resources in private subnet. Okay, so I hope this clarifies some things. Okay, so we have understood subnets and route tables. Okay, now let's see what are security groups. Okay, security groups are, so as, so route table, as you see, route table is nothing but it specify how your traffic is going to travel. But security group is a resource level. Okay, security group acts at a resource level. So what happens is, at a resource level, for example, at EC2 you can attach a security to EC2, security group to EC2. So in that security group, it will it will define, okay, what kind of traffic is allowed to that EC2, and what kind of traffic is allowed from that EC2. Okay, let me repeat. Security group make security group restricts your traffic to and from the EC2 resources, not only EC2 but different kind of resources. So let's see like security groups. Okay, so you see this one. Okay, so this is a security group. Okay, so we give some security group name. Okay, that's fine. Description is also fine. Then we have to specify VPC. It means what this security group should be part of what VPC. Okay, that VPC we have defined here. Now in the security group, if you see, there are two things: inbound and outbound. Okay, inbound means what kind of rules we have to specify for incoming traffic. Okay, what kind of rules that should be should act on inbound traffic. And similarly for outbound section, we will be specifying what kind of rules are going to act on outbound traffic or outgoing traffic. So if you see this here, type is, so there are three inbound rules that are specified. Okay, one inbound, first inbound rule is SSH. Okay, type SSH, TCP protocol, port range 22, source is anywhere. Okay, it means that inbound traffic from any source, it means all over the internet, is allowed only through SSH connection over 22 port number. Okay, so what the first rule says is, you the traffic from anywhere in the internet is allowed to is allowed okay, incoming traffic from anywhere in the internet is allowed only, it should be of SSH type, and whose port number is 22. Okay, and now if you see second rule, similarly in second rule also the traffic is allowed from anywhere in the internet, and the third rule also specifies traffic is allowed from the anywhere in the internet. Okay, but second rule and third rule specifies the traffic type should be HTTP and HTTPS. Okay, it means that if you see overall rule, okay, overall inbound rule says traffic from anywhere in the world or anywhere is allowed only over three different uh, uh, traffic type: SSH, HTTP, and HTTPS. That's it. Okay, so this is how you specify traffic rules on a security group. Okay, obviously these are inbound and outbound traffic, so you can specify different rules for inbound traffic, you can specify different rules for outbound traffic. Okay, and now what you do is you attach this security group to some resources. Okay, for example, you attach this security group to an instance. It means now if I attach this security group to particular instance, traffic from anywhere will be allowed over SSH, HTTP, and HTTPS connection only to my EC2. So incoming traffic to the EC2 will be only of type SSH, HTTP, and HTTPS. That's it. Okay, you can specify different rules, and obviously there are three things that you need to understand: what kind of traffic is there, what kind of protocol is there, what kind of port number or port range is there, and what is the source. These four things are necessary to specify for creating a security group rule. Okay, it can be inbound traffic rule or it can be outbound traffic rule, and then you can attach this security group to your AWS resources. Okay, now what are NACLs? Okay, so this security groups is nothing but they, you security groups are always associated with some resources. For example, it will be associated with EC2, it will be associated with your some database. Okay, but for example, what NACLs does is NACLs specify traffic rules on the network level. Okay, network level means VPC level. Okay, it means if you have this VPC, okay, you can create some NACL for this VPC. Okay, so if you specify some NACL on this VPC, again what you are going to do is you are defining some inbound and outbound traffic rules for that particular VPC. Okay, security groups traffic, inbound and outbound traffic are specified at resource level, but NACLs, inbound and outbound traffic, are specified at VPC level. Okay, and what is this IGW? IGW is nothing but internet gateway. Internet gateway are attached to VPC. Okay, so that you can give internet access to your resources. So it means that there is no direct internet access to any of your resources in AWS. You have to specify internet gateway to your VPC. Only then you will be able to communicate with internet over your AWS resources. Okay, now let's understand what is this NAT. Okay, so as I mentioned here, NAT is, there is something called NAT gateway. Okay, what is NAT gateway? Through NAT gateway, your resources through NAT gateway your resources can communicate to internet. Okay, this is a secure way to make your connection to internet for your AWS resources. Okay, now let's understand what is called VPC peering. So VPC peering is nothing but connecting two VPCs basically. Okay, connecting two VPCs. For example, there are two different VPCs. Obviously, the resources from the one VPC cannot communicate to the resources to the other VPC. But if you want your resources from one VPC to communicate with other VPC, you have to introduce VPC peering. Okay, VPC peering is always one-to-one peering. Okay, so for example, if you have three VPC, VPC A, VPC B, and VPC C, and if you have connected VPC peering on A and B, and you have connected VPC peering on B and C, it does not mean, it does not directly imply that A and C are peered. Okay, you have to specifically connect a VPC peering between A and C also. Okay, and whenever the VPC peering is done, again you will have route tables to define how your traffic will be traveled to different VPCs. Okay, and now this final thing, what is VPN? VPN is nothing but virtual private network. Okay, virtual private network. So basically a different organization has a VPN, okay, their own VPN. So they are nothing but their own virtual private network. But for example, if you want your organization network to be connected with VPC, AWS VPC, then you can do with the help of VPN. Okay, so there is something called VPN gateway. With help of VPN gateway, you can connect your VPC, on cloud VPC, to your organization network. Okay, so this is link of VPC. Okay, the AWS documentation link for VPC. You can go through that. Let me attach some more links. Okay, okay. So that's it for the VPC part. I hope you got some clarification on VPC. What you can do, please go through this first link. Okay, try to get some read some concepts on VPC. You will be able to follow this documentation and understand. You can watch some YouTube videos also on VPC. And finally, what I will suggest is try to do some hands-on, try to do some hands-on labs. uh, Obviously create your own account, AWS account, and you get some free usage, free credits on your own AWS account, and you can try to do some practicals, hands-on labs. Okay, every lab, any kind of a lab will be available on AWS documentation. Okay, now let's see the next topic, that is called elastic load balancing, Amazon CloudWatch, and auto scaling. So here we are covering three topics: elastic load balancing, Amazon CloudWatch, and auto scaling. Okay, actually these three topics are interrelated between themselves. Okay, so let's understand these three things separately, and then I will explain you how these three things are connected. So first is ELB. ELB service allows you to distribute traffic across a group of Amazon EC2 instances in one or more availability zones. Okay, so as the name says, load balancer. Okay, elastic load balancer. ELB means elastic load balancer. So what it will do, this is a AWS service. With help of this service, you will be able to distribute the traffic between multiple servers on AWS. Okay, with help of ELB or with help of elastic load balancer, you will be able to distribute traffic on your different servers. Okay, so this is the basic thing that ELB does. Now if you see, in one or more availability zone is mentioned, obviously this you can see now ELB plays important role in high availability architecture also. Okay, how? Because if your servers are on different availability zones, with help of ELB you can distribute your traffic to different availability zones. Okay, so this is the one of the main thing of ELB. It not only helps to distribute traffic in single availability zone, but it helps to distribute traffic on multiple availability zones also. But obviously all the availability zones must be in single region. Okay, it does not, ELB does not helps to distribute traffic on multiple regions. Okay, it only acts on a single region, and with help of this you can distribute traffic over multiple servers which are spreaded across one or more availability zones. Now you see this, there are four types of ELB. Okay, basically not four types of ELB. um, there are four types of traffic: HTTP traffic, HTTPS traffic, TCP traffic, and SSL traffic. And this all kinds of traffic are supported by a load balancer. So your load balancer is uh, capable to handle all kinds of traffics. Now we will see there are different kinds of load balancer. So first is internet facing load balancers, second is internal load balancers, third is HTTPS load balancers, and fourth is network load balancers. So let's understand each one of them. So basically, internal internet facing load balancer, it means obviously your traffic from internet will be routed to some servers. So that's what internet facing load balancer does. Now what is internal load balancers? Internal load balancers only distribute traffic between within your AWS cloud. Okay, so obviously there are two types. One is capable to distribute traffic from internet to AWS, and one is only capable to distribute traffic within AWS cloud. Okay, so HTTPS load balancers are kind of internet facing load balancers. Sorry, HTTPS load balancers are kind of load balancers which support HTTP and HTTPS traffic, and network load balancer supports TCP and SSL traffics. Okay, so HTTP's load balancers supports HTTP and HTTPS traffic, and network load balancer supports TCP and SSL traffics. So for example, if you want to distribute HTTP and HTTPS traffic from internet to cloud, then what you can do, you can create a HTTPS load balancer, internet facing HTTPS load balancer. Okay, so I hope the load balancing concepts are, you got some idea about load balancer and load balancing concepts. Now let's see what are Amazon CloudWatch. Okay, so Amazon CloudWatch is a service that you can use to monitor your AWS resources, and you can track your applications in real time. Okay, so obviously this is a monitoring service. Okay, so there are things like it helps to collect and track metrics. Okay, like what kind of metrics? For example, how much what is the storage of particular bucket in S3? Okay, or what is the CPU usage of particular EC2 instance, or what is the capacity of elastic block storage, available capacity, or for example how much throughput a particular EC2 is working on. So these kind of metrics, it not only collects them metrics, but it can tracks. So what you can do is just create an EC2 instance. In that EC2 instance you will be able to see different graphs. Okay, those graphs are nothing but metrics. then CloudWatch helps you to create alarms, and that sends notification. Okay, now what are these alarms? Okay, alarms means if something happen, then you can create alarm for any kind of event. You can create alarm in using CloudWatch. So for example, if your CPU usage of your EC2 is more than 80%, then obviously it is overloaded, and the things might get slow, or things might get stuck. So you need, so what you can do, you can create alarm that if your EC2 CPU usage is more than 80%, you can get an email or you can get some kind of notification. Okay, so this is what you can do using CloudWatch. Okay, so there are two things. There is one metric that I just explained. Okay, there are different kinds of metrics like CPU usage. Okay, S3 bucket, data size. Okay, and there is another thing that is called CloudWatch logs. Okay, logs means all the thing that is happening in your AWS account. For example, you created a AWS EC2 instance, so your information will be logged that a particular EC2 instance was created by particular user. Then what you do, so for example, you deleted that instance, then that information will also be get logged. For example, if you created some VPC network, that information will be logged in Amazon CloudWatch logs. So CloudWatch logs is nothing but it contains all the information that is happening in your AWS account. Okay, so two things. Okay, that as per the cloud definition of CloudWatch, monitoring is done using CloudWatch metric. Okay, and tracking real-time application is done using CloudWatch metrics, and all the things that's happening is logged into CloudWatch logs. Okay, so this is the basic of CloudWatch. Now let's see what is auto scaling. So auto scaling is a service that allows you to scale your Amazon EC2 capacity automatically by scaling out and scaling in according to criteria that you define. So obviously, as the name says, auto scaling means it is capable to do automatic scaling. Now, what is scaling? Like I covered this part in earlier lecture also. Scaling is nothing but increasing or decreasing your capacity. So for example, if you have one EC2, okay, what you can do, you can create another EC2. For example, now you will have two EC2, then you can create another EC2, you will have three EC2. For example, now if you have three EC2, you can delete one EC2, now you will have two EC2, then you delete one more EC2, now you will have one remaining EC2. So basically what's happening here is you are scaling in and scaling out. Okay, now actually the thing here is automatical scaling. Okay, automatical scaling. So how it is done? It is done it is done in using the something called auto scaling. Okay, so what you have to do, first of all, you have to create launch configurations and you have to create auto scaling group. So what is the launch configurations? In launch configurations, you define like from what AMI you have to create EC2 instance, what kind of EBS block storage you want for your newly created auto scaling group. Okay, uh, and different kind of things like how auto scaling is done. So if you see, there are three ways that auto scaling is done: manual scaling, scheduled scaling, and dynamic scaling. So manual scaling is pretty simple, like you manually create one more instance or you manually delete one instance. And what is scheduled scaling? So scheduled scaling is nothing but you can scale in and scale out based on some schedule. Okay, so for example, at 7 p.m. tomorrow you want to scale in, so you can create that. And again after 2 hours, for example 9 p.m., you want to scale out, then you can create those scheduled scaling rules. Okay, and what is dynamic scaling? Dynamic scaling is nothing but scaling based on some metrics. Okay, scaling based on some CloudWatch metrics. Okay, so for example, if CPU usage is more than 70%, scale. Okay, it means create one more instance. So what will happen if you created another instance? Your traffic will be your traffic will be distributed and the overall CPU usage will be reduced, so that your task will be performed very smoothly. Okay, and for example, if CPU usage is less than 10%, so what is happening in that case? In that case, your EC2 instance is like not utilized more. So what you can do, you can scale out. You can say, like, instead of two instances which are at 10% CPU utilization, just delete one instance, so all the traffic will be routed to one single EC2 instance, and which will be operating at 20% CPU utilization. Okay, so what you have done, you have dealt with the cost optimization. So you see, dynamic scaling will help you to do the auto scaling based on some metric. Okay, so that everything is specified in launch configurations. Then you create auto scaling group. In auto scaling group, you define how many number of maximum servers you want, how many number of minimum servers you want, and what is the launch configurations, and there are some health checks that has to be done. Everything is specified in auto scaling group. Okay, so now I hope you have idea about auto scaling. So now let me explain you how these three things are put together. Okay, elastic load balancer, Amazon CloudWatch, and auto scaling. So obviously the first part is auto scaling. You want auto scaling, okay, that's done. But if you have done auto scaling, you have created multiple servers. How the traffic will be distributed? Traffic will be distributed using elastic load balancer. Okay, so you see, let's see the diagram of. Okay, so let's see this diagram. So what's happening, there is some load balancer here first of all. So everything is a part of VPC. So if you see, you have VPC, then you have two different subnets. Okay, in the left side there is subnet 1, in the right side there is subnet 2. Okay, both subnets are in different availability zone. Then there is load balancer. Load balancer will distribute traffic to different availability zone, and between this availability zone there is auto scaling group. Okay, it means auto scaling is happening in subnet 1 also, and auto scaling is happening in subnet 2 also. Okay, so this is how it is done. Like load balancer and auto scaling group are always connected. So if you are having auto scaling group, you will have a load balancer. And how auto scaling is done? Auto scaling is done using CloudWatch metrics. Okay, so I hope it's clear how these three things are interconnected. For auto scaling group, you will require elastic load balancer and you will require CloudWatch. But obviously, to use elastic load balancer, there is no need to do auto scaling. Elastic load balancer is different thing, and CloudWatch is also different service. You can do lot of things apart from auto scaling. Okay, so I hope this is clear. So this is it for today from my side. Do you have any questions? Let me know, or else you can drop off.